What if I told you that Kansas, smack in the center of the United States, once had a shoreline, and beyond that shoreline was an ancient world of creatures long extinct? It sounds like a myth, but it was once reality. Imagine standing in the middle of those endless wheat fields today, only to realize that you're standing on the floor of a vanished ocean or massive lake. Now, what if I told you that Native Americans guided colonial explorers in search of what they called inland seas? Early map makers, working from indigenous knowledge, sketched coastlines deep in the American interior. Their stories of deep water and lost shores may not have been folklore. To modern eyes, the American interior is just grassland, desert, and rocky mountains. But the rocks remember. The geology remembers. They whisper of armored fish, drifting ammonites, and even the footsteps of human ancestors. Today, we'll follow the clues these waters left behind, and it'll take some detective work. Deciphering what the Native Americans were talking about is still not perfectly clear. Uncovering the ghost lakes that once stretched across the landscape is no easy task either, but it's a story worth digging up. It's a reminder that the world we live in now is not permanent. What we see around us will inevitably change. We can confidently say this because we now know that at various points throughout history, much of North America was underwater. Old maps of North America sometimes depicted inland seas. One labeled Appalachian Salt Lake was closer to the Atlantic coast. The Sea of the West is sometimes seen in the northwest. But did they ever really exist? It began with English explorer John Smith. During his capture by Native Americans, they told him that a great sea lay just a few days' walk from the coast. Smith's hand-drawn maps and letters described a river at the 40th parallel that led to this secret sea. It was also suggested that it connected to the Pacific Ocean. He sent these reports to his friend Henry Hudson. Like many Europeans of the time, Hudson was hoping for a shortcut to Asia. He never found the sea, but Hudson did stumble upon a new river, which we now call the Hudson River. By the 1700s, rumors of this mythical sea had spread across European cartography. Jean-Baptiste Nolan famously published his 1775 map, including the Sea of the West. But he was later sued for plagiarizing earlier manuscripts. In reality, it was French geographer Guillaume Delisle and his brother who first sketched the Sea of the West on private manuscripts in 1695. In doing so, they hoped to spur French expeditions. Delisle claimed that the Spanish caught a glimpse of it on their explorations. Importantly, Delisle's brother even warned on his map that the sea was not yet discovered, but known to the natives. Since the European map makers never saw or surveyed the seas themselves, the maps were certainly flawed. They relied entirely on second-hand reports, filtered through native traditions. Sioux elders described a Great Lake with stinking water. They also said it was reachable by river in 15 days. Similarly, the Illinois peoples were familiar with the Western Sea. They recounted how their ancestors had been driven inland from its shores by rival tribes. It wasn't until the 1780s, after systematic coastal surveys and explorations failed to find any entrance, that the Sea of the West finally evaporated from serious maps. And scholars still debate why this sea stubbornly clung to maps for so long. So where did this big misunderstanding come from? Were the Native Americans conspiring against the Europeans to guide them away from their homeland? It's possible, but we also have to recognize the language barrier at these early stages of American colonialism. Context, locations, and timelines certainly could have been lost in translation. There was also the inherent bias of the Europeans desperately trying to find a quick pathway to Asia. The most likely explanation is that Native Americans were referring to real bodies of water, just not massive seas. The Great Lakes are the most probable. In fact, we do have archaeological evidence from the East Coast showing the presence of copper bands derived from the Great Lakes area. In the other direction, shell material from the East Coast has been found around the Great Lakes. This suggests that long-distance trade and/or migrations between the regions existed, and these people most probably knew of each other. And perhaps indigenous knowledge is deeper than we know. Maybe these groups were aware of massive lakes that once existed and have since disappeared. On this note, we have to consider the oral traditions of these groups. They did not practice writing and documentation. What they knew was from experience or taught to them by elders. The stories that they told each other were full of valuable information. and moral codes, like a spoken Bible. Could the natives have been referring to bodies of water that their ancestors exploited for resources, but have since vanished? Let's explore what some of these could have been. Geologists have discovered countless lakes across the Americas, which existed thousands of years ago. They are sometimes referred to as paleo lakes or extinct lakes, being that they have since dried up or vastly shrunken. At the time of their existence, people were certainly here, and like all humans, they would have relied on water and the resources that flourished along with it. We now know that the human presence in the Americas was well established by 13,000 years ago. I'm sure you're aware of the Clovis culture, for example, who inhabited North America coast to coast at the time. I've talked about them quite a bit on this channel, and I'll leave a link to my video on Clovis in the description. But real quickly, they were nomadic hunter-gatherers who migrated along rivers and shorelines whenever possible. That said, people were most likely here well before Clovis, as we'll discuss later. So what lakes and things did these ancient Americans witness that we no longer can? Starting on the East Coast, we have Glacial Lake Passaic. It was located in northeast New Jersey and reached its maximum size between 13,000 and 11,000 years ago. At that point, it was about 30 miles long, 10 miles wide, and up to 200 feet deep. Now, that same location is full of entire towns and swampy wetlands. So where did Lake Passaic come from, and where did it go? Really, it started around 220 million years ago. Let me explain. New Jersey and North America were once connected to Africa in one supercontinent called Pangaea. Then, around 220 million years ago, the tectonic plates under these continents began to spread apart. When land dramatically pulls apart like this, it can often form deep basins or depressions, which is exactly what happened to the east coast of America. Glacial Lake Passaic was located in what's called the Newark Basin. This was one of the many depressions caused by the separating of the continents. Geologists have identified a whole chain of these along the east coast. You also get magma intruding through the Earth's crust during tectonic events like these. This is because the crust is thinning and getting weaker. In the Newark Basin, volcanic rock known as basalt intruded and created 3 curved mountain ranges called the Watchung Mountains. The name comes from the Native American term Watchunks, meaning high hills. These formed a bowl shape, ideal for trapping water. Fast forward to the Illinoisan glaciation around 150,000 years ago, the Laurentide ice sheet barreled into the Newark Basin. Water pooled within the Watchung Bowl, forming the first incarnation of Lake Passaic. Eventually, that ice began to recede. Then, the late Wisconsin ice sheets advanced around 20,000 years ago, at the last glacial maximum. This filled Lake Passaic once again. Only a few openings within the Watchung Mountains allowed for small amounts of water to drain. As that glacier began to recede, its meltwater supplied Lake Passaic, but that meltwater eventually started to carve some larger openings. When ice continued to retreat due to global temperature increases, the water crashed through some of these openings. One of these events, the Great Notch Opening, dropped the lake level by about 80 feet in a sudden flood. This torrent sculpted today's river valleys in the towns of Montclair and Clifton. After 12,000 years ago, Glacial Lake Passaic continued to steadily drain into the Passaic River, and finally, the Atlantic Ocean. Standing atop Watchung Mountains today, you mostly see modern neighborhoods, muddy floodplains, and even New York City in the distance. But 13,000 years ago, Clovis hunters were standing in the exact same spot. No neighborhoods and no industrial cities to be seen. Just forest and a massive lake. The most industrial technology they had was their Clovis point, an artifact today, but an essential tool back then. It wouldn't have been made from the basalt of the Watchung Mountains. That doesn't make for a great toolstone. Instead, they probably acquired chert from outcrops many miles to the northwest. They quarried and knapped it there, then carried it on their long journeys. Arriving at Glacial Lake Passaic, they would have been accompanied by the typical megafauna of North America, like mammoths and mastodons. These Native Americans were living in a world of giant lakes and giant beasts long gone. Moving just west of the Great Lakes, we come to a truly enormous body of water, Lake Agassiz. This was a leviathan of Ice Age North America. It was vast, deep, and ever-shifting. It too began as a prisoner of ice. In 1823, geologist William Keating marveled at the quote-unquote defect of the Red River Valley's flatness. It's an unbroken plain located in North Dakota, surrounding states, and parts of Canada, and it's so level it fooled the eye. That flatness is the legacy of a vast glacial lake. About 11,700 years ago, the huge Laurentide ice sheet began sliding back north, leaving a deep trench in what's now the Red River Valley. Meltwater collected behind the icy edges, just like water filling up behind a blocked bathtub drain. At first, a small channel acted like a leaking plug, letting water spill into the Minnesota River. But as the ice walls grew stronger, the drain stayed plugged and the bathtub filled up. It's a similar pattern as we saw with Glacial Lake Passaic. Over the next 2,700 years, this icy bathtub didn't stay the same height. Whenever the meltwater would carve a new route going east toward Lake Superior, the water level would suddenly drop, like opening the drain a little bit. Then if those channels refroze or got blocked again by ice, it was as if someone closed the drain. The water backed up, rising higher and higher. Each time the water settled at a new level, it left behind sandy bathtub rings. Geologists today still find those old beach terraces and layers buried beneath fields. They call them ghost sands. In all, Agassiz covered some 365,000 square miles, 5 times North Dakota's size, though never all at once. Its final breach was around 9,000 years ago. Eastern ice dams gave way and unleashed a flood toward Hudson Bay. So huge, it may have triggered a sudden North Atlantic chill. Having existed until 9,000 years ago, it surpassed the Clovis era. At this point, new Native American cultures were emerging. Some were using novel variants of fluted points. Others were developing different kinds of stemmed or notched points. Those were often made from different stone material too, replacing chert with rocks like rhyolite and quartzite. The beginnings of what archaeologists call the Archaic period were emerging. These people were adapting to a warmer, wetter world. Unlike Clovis hunters, who likely chased mammoths in small, highly mobile bands, Archaic groups started settling near rivers, lakes, and coasts in semi-permanent locations, but they still never settled down for good. They crafted groundstone tools, woven baskets, and fishing gear. This all supplemented a diverse diet of fish, nuts, and plants. As ice sheets and glacial lakes shrunk, forests spread, and sea levels rose. Seasonal camps replaced transient kill sites. Trade networks and social ties grew stronger as groups learned to live off a wider variety of resources. Despite the vanishing Lake Agassiz, indigenous elders could have certainly passed down stories of its once humbling size, speaking to generations only a few years too young to have experienced it firsthand. Lake Agassiz and its decline are a prime example of the dramatic climate shift early Americans witnessed. Today, only scattered lakes, much smaller in size, remain in its place, reminding us of their older, bigger brother. The last big lake we'll talk about is going to bring us to the forefront of human migrations into the Americas. If you're a fan of this channel, you probably already know where I'm going with this. It's an archaeological site I've discussed a few times. It's called White Sands, and it's in New Mexico. It's a great fit for this video in that it was once a big lake called Lake Otero. However, some new papers were recently published with even more insights into the archaeology of the site, so let's check it out. At the same time, the Newark Basin was forming. As North America was separating from Africa, the Southwest wore a very different face. A shallow sea draped over today's White Sands. The salty sea laid down thick layers of gypsum, a soft, fine mineral, white to gray in color. Fast forward 70 million years, and colliding tectonic plates thrust the Rockies skyward. Then, 30 million years ago, the land ripped open. The San Andreas and Sacramento Mountains split into different ranges, forming the Tularosa Basin between them. Waters eventually settled into that basin, giving birth to the 6,000 square mile Lake Otero. So unlike the last two, this lake was not glacial in origin. That said, it did start to shrink around the same time as the other two. Rather than draining into bigger bodies of water, much of Lake Otero's water evaporated. This left behind the gleaming sands called Alkali Flat, full of the gypsum that never evaporated. Then came the wind. Powerful gusts battered those gypsum crystals, grinding them into brilliant white sands. The sand dunes grew and shifted to form what we see today, the largest gypsum dune field on Earth. But a little over 20,000 years ago, pre-Clovis people got to see it in a much different state, though some are still hesitant to believe this fact. It was first proposed in 2021 when archaeologists published a paper describing human footprints they found at White Sands, dating to about 23,000 years ago. They found extinct megafauna tracks too, from species like mammoths and giant ground sloths. One ground sloth track even had a human footprint within it. Makes you wonder what it was like to be walking around those giants during the last glacial maximum. This initial study was bold and met with criticism. No one had ever presented such clear evidence of people in the Americas that long ago. Critics challenged both the ages and the context. Rupia seeds were the aquatic plant material that was radiocarbon dated. Skeptics mainly argue that they were subjected to the hard water effect. This means that old carbon can be introduced into aquatic plants and yield artificially old ages. Pollen grains found within the tracks also dated to the same time, but pollen can drift on the wind and redeposit, which also muddies the true ages. Others posited that the nearby lake history was poorly understood. By misinterpreting sediments and the times they were deposited, the footprints might not be as old or as clearly linked to LGM paleo environments. That said, a new paper by Vance Holliday and colleagues tackles these concerns head on. By the way, I wrote about this paper shortly after it came out in my newsletter, so if you want to stay up to date on what's going on in the world of archaeology and human evolution, you can subscribe to that for free using the link in the description. But back to the paper. The researchers conducted a new independent study of Paleo-Lake Otero deposits. They recorded another high-resolution stratigraphic and geochronological record and found that their deposits aligned perfectly with the track-bearing deposits. They also collected 26 new radiocarbon dates. These came from more rupia seeds, but also additional organic matter from ancient muds. Think of it as an old layer of wetland with wetland-type grasses or shrubs. The dates for these samples were then produced by two labs entirely separate from the original study. The new seed and wetland deposit dates aligned with a 23 to 17,000 year old range. Importantly, isotopic analyses demonstrated that the muds were not simply contaminated by old carbon from aquatic plants. This ended the hard water problem. By weaving together three independent sources of radiocarbon, which were the seeds, pollen, and bulk deposits of wetland mud, with robust stratigraphic mapping and sediment analyses, a clear case has been made. The White Sands human tracks really do date to the last glacial maximum. This study reaffirms what was already groundbreaking, that people were walking the margins of Paleo-Lake Otero 23,000 years ago, leaving Ice Age footprints in the sands of New Mexico. Oh, and one last paper I wanted to mention that I thought was pretty cool. Alongside the footprints lie long, linear grooves, what scientists believe are echoes of prehistoric transportation methods. They found three different groove types. First are single, narrow trenches that slice through footprints in straight or meandering lines. Second are wider, shallow runnels that often chop off one side of a footprint. Third are twin parallel grooves, about 25 to 35 centimeters apart, with prints nestled between or beside them. No animal tracks accompany these features, only human tracks. After ruling out natural causes, researchers conclude these scars were made by travois, simple wooden frames hauled by humans to carry food, tools, or hides. Each groove marks where the wooden poles scrape the soft ground. This discovery hints at the world's earliest transport technology. Picture the journeys of ancient people moving goods across Ice Age landscapes. What were they carrying? Was it food supplies for long treks? Could it have been a fellow tribesman, injured and in need of help? These are deeply interesting questions that make us think about what life was actually like back then. These drag marks offer a rare glimpse of how our ancestors possibly harnessed simple machines to master vast, forgotten landscapes. Lake Otero may be the oldest paleo lake North Americans ever saw, but I want to take you even further back in time. Let's leave the realm of archaeology and jump into some deep paleontology, to a time well before humans ever existed. The western interior Seaway was a massive inland sea that existed from around 100 million to 66 million years ago. This ancient sea connected the Gulf of Mexico to the Arctic Ocean, effectively splitting North America into two distinct landmasses, Laramidia in the west and Appalachia in the east. At its peak, the Seaway was 2,500 feet deep, 600 miles wide, and stretched over 2,000 miles long. If the Seaway was still around, it'd cover states from Texas through Kansas and up to Montana and the Dakotas. It left us with some wild geologic features. The monument rocks of western Kansas are some of the most fascinating. They look so out of place, rising vertically, but surrounded by otherwise flat plains. These outcrops of sedimentary rock reach about 70 feet in height in some places. They're made of Niobrara chalk, which formed around 80 million years ago on the seabed of this ancient ocean. A form of phytoplankton called coccoliths lived in the western interior Seaway, and this chalk is the accumulation of their remains. The Niobrara Formation underlies much of North America's Great Plains, but at Monument Rocks, we get to see it in full effect. One of the most photographed features here is the Keyhole Arch. Local legend says that it started as a tiny puncture from someone shooting toward the rocks many years ago. Over the decades, it's continued to hollow out from those small bullet holes into the large glowing portal we see today. Due to erosion and gravity, it's been silently widening until one day the ceiling will give way. At this point, only delicate stone spires will remain. But that's just some of the geology. Existing during the Cretaceous period, the western interior Seaway was a hotbed of ancient life. Imagine cruising these warm, shallow waters alongside plesiosaurs. These were sleek, long-necked reptiles that ruled the depths. Here, sharks like Squalocorax prowled on prey. Above them all lurked Siphaxtinus, a 4 to 5 meter bony fish larger than most today. Below the surface, microorganisms like coccoliths, foraminifera, and radiolarians spun chalky plates and glassy skeletons that would one day form vast limestone cliffs. Ammonites and belemnites drifted around like underwater rockets. Fossils from winged species have also been found near the Seaway shoreline. Flightless birds known as Hesperornis traveled around these waters with powerful legs and tiny wings. Some of the earliest known flying species belonging to the pterosaurs clade hung around here too. These included the massive pteranodon, and they were huge. The average wingspan of this creature for an adult male was about 18 feet. For perspective, the bird with the largest wingspan today is the wandering albatross. It only reaches about 11.5 feet. On the seafloor, thick muds held little oxygen, but some oyster-like bivalves thrived there. Their giant shells, some over a meter wide, littered the bottom, creating reef-like havens where schools of fish sheltered. Their calcite crystal shells still sparkle in fossil form today. They're a pearly echo of the lives that once lived there. Every fossilized tooth, shell, and skull offers a glimpse of a realm where giants swam, birds dove, and plankton built chalky foundations. The western interior Seaway may be gone, but its secrets lie buried in rock, waiting for our curious eyes to uncover their mysteries. So to bring it all together, North America has by no means been a static continent. Many of the early maps depicting inland seas were most likely based on myths or misunderstandings. However, archaeological and geological investigations show us that there were many times when modern lands were underwater. During the time of early indigenous habitations, we find archaeological sites and human footprints in and around these giant extinct lakes. Millions of years before them, we find extinct animals that once inhabited ancient seaways. And so if you find these sort of mysteries fascinating, you'd probably be curious about what happened when the North and South American continents collided. To find out, give the video on screen a watch. Don't forget to like, subscribe, and share. Thanks for watching. I'll see you in the next one.